Good morning, class 7. Welcome back to our class starting after the unit test. Today, our topic of discussion is the next chapter, that is sound. Sound, as I am talking to you, what am I producing? I am producing sound. So, sound is also referred to as a form of energy. Okay, earlier we had studied light, we have studied heat. So now again we are studying sound. Now these are different forms of energy through which energy moves from one place to another. Now you can also feel the energy of sound. If you, while talking, if you place your mouth near your mouth, hand near your mouth, and then you start speaking, your hand will feel some gush of energy. That is a gush of wind moving out through your mouth as you are talking. That is nothing but the vibration of the particles of air. As you are speaking, the particles of air in front of you starts vibrating, and that vibration makes a chain reaction through which one molecule disturbs the other molecule, that molecule again disturbs the molecule in front of it, and this is how the sound or the vibration, should I say, the vibrations move forward, and these vibrations produce sound. So, few things that we need to know about sound. First of all, sound is a form of energy. Secondly, sound needs a medium to travel. A medium can be anything. It can be any solid medium, liquid medium, gas medium, like air around us. As I am speaking to you, between me and you there is air. Okay, when you sit in the classroom and as teacher speaks to you, between you and the teacher there is air in between. So when the teacher speaks to you, the air in front of the teacher starts vibrating, and that vibration creates a series of chain reaction through which one molecule of air vibrates and disturbs the other molecule in front of it. That molecule again vibrates and disturbs the next molecule in front of it, and this is how the disturbance is created, and that disturbance reaches your ears. Your ears receive the sound. You have the eardrum inside your ear which starts vibrating as the sound reaches your ear, and then that vibration is perceived by your brain as sound. So sound needs a medium. Without that medium, sound cannot travel. Now, if you go to space, you must have seen astronauts going to space. Astronauts, when they communicate with each other, they cannot just talk like that, because in space it is vacuum. Vacuum means absence of any medium. Total absence of medium is there. So, astronauts over there cannot communicate just by talking to each other. They need some radio device which is connected to their ears. There is a mouthpiece through which they communicate, and the signals are transmitted just like how you transmit through mobile phones. You talk through one mobile phone and that signal is transmitted to the other mobile phone. Similarly, in space also, when people have to communicate, they cannot just communicate as we communicate with each other, no? One in front of the other, and then talking to each other. It cannot happen in space. Space has no medium. Space is an absence of medium. So there is no molecules of air over there which will vibrate when you speak. And since there is no molecule of air over there, so the vibrations cannot be produced, and that vibration will not produce any disturbance which will reach your ear. Alright? So sound needs a medium, and this medium, the more the thickness or the more the density of the medium, the faster the sound will travel through it. Sound travels fastest in solid mediums. Okay? Solid mediums have the greatest amount of density of molecules in them, followed by liquids. Liquids, the density of molecules is lesser than solids, because less number of molecules are there compared to solids in a given volume of space, and the least number of molecules are there in gases. So sound travels the slowest in gases, fastest in solids, slower in liquids and the slowest in gases, and does not travel at all in vacuum. Vacuum is where the absence of medium is there. There is no molecules of medium. So sound needs a medium. Third thing is about sound that you need to know. Sound moves by the vibrations of the particles of the medium. Now this thing I have to explain. I will use the blackboard to explain to you. As you can see over here in the blackboard, I have tried to draw the head of a person. May not exactly represent a person, but understandable. Okay, so here is the person, and in front of him, these are the molecules of air. Now we know molecules of air are quite far apart from each other. So here are the molecules of air. Now when this person starts speaking, then what will happen to these molecules? When the person speaks, he generates energy, sound energy. And energy moves forward, right? So energy cannot remain in one place, it moves forward. So as the energy, sound energy moves forward, let's see what happens. These molecules starts to be disturbed, they start to vibrate. As you can see over here, I have drawn a few arrows here. Okay, I hope you can see properly. These arrows represents the vibration of the molecules. These molecules, they start vibrating to and fro about their fixed positions or their mean positions, so to say. So when they start moving to and fro, it's like when you stand in a line, okay, and one person generates a push, then what happens to the next person in front of the line? That person also gets disturbed, right? So he will also generate a push. Then that person who is ahead of that next person will also be disturbed and he will also generate a push. So that push is transmitted from the place where it is generated to the forward direction. So this is the same thing that is happening over here. These are the molecules which are in front of the person. As the person starts to speak, he generates energy. That energy moves forward through these molecules which start vibrating. When they start vibrating, moving to and fro, they disturb the next molecule which is in front of it. And then that molecule disturbs the other molecules in front of it. So that creates a series of disturbance which is known as wave. As you can see, these lines that I have drawn over here, these are known as waves. These waves are generated by vibrations of the molecules. So this is how sound moves forward. So as I had said in the third point, sound moves by the vibration of the particles of the medium. So this is the demonstration of that particular point that I have mentioned. Okay, in this regard, it is compulsory to know what transverse waves are. Transverse waves. There are two kinds of waves, transverse wave and longitudinal waves. So let us first discuss transverse wave. In transverse wave, these are the waves which vibrate or move forward by vibration of particles. How they vibrate? They vibrate perpendicular to the direction of motion of the wave. Now I will explain to you. This straight line represents the original position of particle. Okay? So in this, say the molecules were like this. But when the wave starts, then this particle moves upward and comes here. This particle moves upward and comes here. This moves here and comes here. This particle moves downward. This also downward here. Again coming upward here. See, the particles which were in one line before, when the wave starts, these particles move, some particles move upward, some particles move downward, some particles move upward, downward, alternatively. This is the motion of the wave. You can see this wave-like thing. This is created because of the motion of the molecules. This motion, this molecule moves upward, this molecule moves upward, here the molecules move downward, these molecules move downward, and so on. Alternatively, they move up and down, creating a wave pattern which looks like this. The wave moves like this. Best example I can tell you, when you take a chadar, okay, bed sheet, and then when you give it a force like this, then you will see a wave created in that chadar, in the bed sheet, and that wave moves forward. If you are standing here and you give the chadar a turn like this, then the wave pattern that creates the energy that moves forward because of the upward and downward movement of the particles of the chadar, the bed sheet. So this is how. So as I had said that the molecules, okay, the molecules, they vibrate perpendicular to the direction of motion. Direction of motion is this horizontal line, and the vibration takes place perpendicularly, sometimes upward, sometimes downward, sometimes upward, sometimes downward, and so on, alternatively. So such kind of vibrations create transverse waves. Okay, I hope this is clear to you. Where the motion of the particles of the medium takes place perpendicular to the motion of the wave. In that, we say the wave that is generated is transverse wave. Alright. Next is longitudinal wave. Okay, longitudinal waves is somewhat opposite to transverse wave. In this, the particles vibrate along the direction of the motion of the wave. Earlier we saw transverse wave, the particles vibrate perpendicular. If the motion of the wave is this way, then the particles vibrate perpendicularly. Perpendicular means you all know at 90 degree. In this case, if these are the particles, if the wave is created, then these particles will not vibrate up and down. If this is the direction of the wave, this is wave direction, then our particles will also vibrate along the same line, as the motion of the wave direction. They will vibrate to and fro, left and right, along the direction of the wave. Okay, so this is how. So in some places the vibrations will be very close to each other, and in some places the vibrations will be far apart from each other. Okay, the vibrations in which the molecules are further apart, and in some places where the molecules are closer together. Okay, the place where the molecules are closer together, there we say that that region is your compression region. Okay, where the molecules are close to each other, the region is called region of compression. Whereas the region where the molecules they vibrate further apart from each other. See the distance compared to here. Here the distance is more in this region. From here to here, Okay, thus this region where the molecules vibrate further apart from each other, that region is known as region of rarefaction. Okay, compression where the molecules are vibrating close to each other, rarefaction where the molecules are vibrating away from each other. Okay, so now we know two kinds of waves: transverse waves where the molecules vibrate perpendicular to the direction of motion. If this is our motion of wave motion, then the particles of the medium vibrate perpendicular to the wave motion. That is called transverse wave. Whereas in longitudinal wave, here the waves in these particles will vibrate not perpendicular but in the same line as the direction of wave. Alright. Now the question arises, we are dealing with sound, right? So sound comes under which category of wave? Whether sound is transverse wave or whether sound is longitudinal wave. Sound is longitudinal wave. Okay, you see here the arrows that I have drawn. See the arrows. These arrows indicate the direction of vibration, right? Our sound is moving this way, and in which direction are the molecules vibrating? The molecules are vibrating in the same direction as the motion of the wave. So our sound comes under the classification of longitudinal waves. Okay, I hope I have made myself clear. So today we will keep till this much only. We will continue further in the next class. Thank you for attending today's class.